Hello guys, I'm back. Today I will share with you some comments related to flame arrestor. What is it and how it is used in chemical process engineering and plant design. My name is Jeferson Costa and I teach students, graduates and engineers how to work with chemical process engineering and plant design. Follow my profile and like this video to get hundreds of content related to chemical process engineering and plant design. I received a question on my YouTube channel to talk about flame arrestors. And the question was, could you please talk about flame arrestors, sir? So today let's talk about that. In a few words, flame arrestors are a kind of device that is used to prevent the backflow of a flame in an ignition system. So think about a flash system where you have the stack and in the top of the stack we have a flame. If some kind of issue happens with this combustion, the flame can flow back through the source of the ignition and go to the storage or the flammable source that you have. So to prevent this kind of situation that will lead to a hazard condition and can generate or can lead to an accident, incident, and etc. Sometimes it is used flame arrestors in the project. There are basically three types of flame arrestors. We have the inline flame arrestor that is used or installed in a pipeline, where in many cases in the basis of a flare, for instance. We have the end user flame arrestor that can be installed in a vent. For instance, you have a vent for atmosphere when you have a tank open to atmosphere, and in a case of the ignition of this vent, you can have a flame arrestor to prevent the backflow of the flame, and we have a combination of both of them, the inline with the end use flame arrestor. The principle of use or the principle of work of a flame arrestor is that you will have like a filter in your pipeline or in the end use that will prevent the backflow of the flame. The device will absorb the energy of the flame, and with that will be able to extinguish that and let the process to a safe condition. Some of the concerns about using flame arrestors is that that is like a filter that is designed to let the fluid go through one side and not let the flame return from the other side. It will add a pressure drop to your system, even though it can be as small as possible. You are adding a restriction to your flow, so it must be very well designed. And inline flame arrestors, the diameter is much bigger than the normal pipe header. And because of that, depending on the kind of fluid that is passing through of your flame arrestor, it can block the flame arrestor, and with that cause another issue, that is the stop of protection from the release of your process. So most attention or big attention must be added to this kind of behavior that you can have in the flame arrestor. As a chemical process engineer working with plant design, you will be responsible for deciding if a flame arrestor is needed or not to your process. And if it is needed, you will need to add that to your piping and instrumentation diagram. So here you can see an example of a flame arrestor installation that is in the basis of a flare stack. So in this drawing, I have the flare stack, and to prevent the backflow of a flame that can happen in this kind of flare, we have here the installation of a flame arrestor. Then that, as I told you, can have the problem of obstruction. So you must make sure that you are able to identify if your flame arrestor is blocked or not, or if it is increasing the pressure drop in your flash system, and you need to have a way to clean that without, preferably doing the cleaning without stopping the plant. So here you just have an example of a flame arrest installation. But all flares will have a flame arrestor, not necessarily. In this new drawing, you can see a flare stack also, but there is no flame arrestor installation. And in this project, there is no flame arrestor installation because although I have this stack here and I can have a backflow to my flare system, in this design, I have a seal of liquids to prevent the backflow of a source of flame. So in this case, my header will release the combustion or the flammable gases through a seal of liquid, and when the mix passes through the seal of liquid, it goes to the flame tip, will be burnt, and if a flame returns, the flame of liquid will be responsible for not letting have any kind of issue or accident in this system. If you want to know more about chemical process engineering in plant design, take a look in the next video that will appear to you right now. This is it. I hope you like it, and I'll see you soon in the next video. Bye bye.